what is the practice that we usually have when we come into our class? And let's keep up that practice. Let's take out a piece of live paper. Yes, I cannot find my hole puncher, so we'll have to live without a hole puncher for now. No sharing of stationery, unfortunately. I do have a hole puncher somewhere. I'll find it eventually.
Maybe with a couple of 120.
Thank you.
Is this here for
Wait. Try not to, guys, try not to put stuff into the desks.
Wait, there's a book inside.
Whatever that we put inside, can you please take it out?
look at the water though.
Whoa!
There's a high shoe out there.
It's a great.
The memories of
There are a lot of papers inside.
Just don't put anything in there. So that if you don't put anything in it, then you're not going to forget to take it out.
Remember that?
Thank you. So I can see most people are ready. Good. Do you have any paper right now? Well, for tomorrow, can you please bring some paper for tomorrow? For today, I will allow sharing of my paper. Kyle needs one too. Thank you, Ria. Paper. Oh, okay. Thank you. I have no idea who has been taking notes or who hasn't been taking notes. I know there are some people who have been diligently taking very neat notes. Thank you to those of them. Thank you to you who have been taking notes. I know some of you have posted your notes onto your OneNote. Well done. I have seen them. It looks very good. They're not mandatory. Notes aren't mandatory for you to post, but there are some people who like to make use of their OneNote and post their notes there too. Last lesson, we talked about independent events. Now, just to summarize a little bit what independent events mean, it is two events in which the result of the first event has no impact whatsoever on the second event. So it doesn't affect the second event at all. So I use an example over here of taking out one marble at random, and then if I put it back, then it's the same number of marbles in the bag. So no matter how many times I do it, it doesn't affect the next draw because it's the same. Whereas today we're going to talk about dependent events. So we'll be talking about dependent events today. I will make it a little bit bigger. Is that easier to see? So dependent events is the opposite of independent. It means that if the result of the first event changes the probabilities of the second event, then the two events are dependent. Now, let me just quickly copy that same bag of marbles. Technology, how nice. I don't have to write it again. So in this same bag of marbles over here, this time if I take out one marble at random and keep it, then take out another marble at random this time I'm going to do two questions, A and B. What is the probability of taking a red first and then a green second? And then for part B, let's do what is the probability of taking a green first and then another green. So there are two probability questions. Oops. Now these are dependent events because the moment I take out one marble, then there's going to be one less marble in the bag, then the whole set of probabilities change. The number of favorable outcomes out of the total possible outcome will change. So for example, if I do take out a blue the first time, there's one less marble in the bag. So the total possibilities will be decreased by one. So let's look at the first question. What is the probability of taking a red first and then a green second? So let's do A over here. So if we want to take out red first, first of all, what is the probability of taking out a red? Well, taking out a red will be 4 possibilities because there's 4 red marbles out of how many marbles in total? So last lesson, I think we counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 4 out of 12. So this is our first draw. Then, in the second draw, there is 1 less red marble. So the next time we count our probability, we'll have to count 1 less marble in the total possibilities. So now, what is the probability of getting a green the second draw, given that we have already taken out a red? So we want to find the probability of getting a green, and then this is going to be a little bit of new notation over here. We're going to say given red. This given red means that we drew a red the first time. So it's assuming that we drew a red the first time.
Is this part 2 of 13?
Yes, this is part 2 of 13.6.
Is it 2 divided by 11?
So if we did drew a red one the first time, then there'll be 1 less red. That means the total possibilities, instead of 12 now, is going to be 11. So I'm just going to cover up one of these red ones. How many marbles are left? There are 11 marbles left. And then if you want to find the probability of green, that's 2 green ones out of 11 marbles. So that this time is going to be in green, that's 2 out of 11 because there's one less marble in the bag. Now, the last part is we need to multiply them together. So in the end, if we want to find red first and then green second, so we'll do P probability of red multiplied by the probability of green given red. That's equal to 4 over 12 times 2 over 11. That's 4 over 12 times 2 over 11, which means that in the end, the next step will be, we can simplify this. 4 over 12 is 1 over 4, right? 1 over 3. So that's 1 over 3 times 2 over 11. That's going to be 2 over 33. So that is the probability of us choosing a red first and then a green marble after that. So this is called dependent events. Or, in other words, it's called conditional probability. It's conditional because it is, we're given the fact that we've got a red the first time. That's assuming we drew a red the first time.
What does the P stand for?
Probability of. P bracket means probability of. So, second part of the question, we want to look at the probability of taking a green first and then another green. So, question B, first of all, if we want to look at the probability of choosing a green the first time, that's going to be 2 out of 12 marbles. So I'm going to write 2 out of 12. And then the probability of choosing a green, given that we have chosen a green the first time, that's going to be P green given green. So this is probability notation. This means the chances of us choosing a green, given that we have chosen a green the first time. That's P green given green. So in case you don't know what the given means, I'm just going to label it over here. This mean is that assuming we drew green the first time.
So right.
And so if we chose green the first time, how many green marbles are left in the bag? There's only one left. So if we did get to choose one green over here, then there's only one left. And how many marbles are left in the bag?
10.
No, we only one from the bag. 11. So now, the probability of us getting green given green is going to be 1 out of 11. And so, if we want to multiply them together, the probability of us getting green times the probability of getting green given that we got green the first time, that's going to be 2 out of 12 times 1 out of 11, which is going to be 2 out of, what's 12 times 11? I'm not good at mental math. 132.
Oh, dang it.
Okay? Yes. Yes, we can simplify it. So that's going to be 1 out of 66. Is that right? Is that 1 out of 66? 60 times 2 is 120. So 6 times 2 is 12. So that's 132. 1 out of 66 chance. So is that a high chance? Not really. It's 1 in 66 chance that you can actually take the green and take the other green. Okay, it's a very small chance. So, I have a second question. Yes, you may. What looks like an A? My G looks like an A?
It looks like an U.
Yeah.
How does that look like an A?
That's what it a bit.
It looks more like an H than a G. Than an A.
The next G looks like an A.
This looks like an A?
Yeah.
Oh, this looks like an A.
Both of them.
Anyways.
Mystery.
There you go.
I thought you drew pi for a second.
Is that better?
Yes.
Is that better?
Look at the arrow. Oh yeah.
So, let's do another example. So, in this example, I have no idea what the fish.
What do you see this as?
Okay, so in this example, you work at a dog kennel, and so in this dog kennel there are 3 black, 4 brown, 2 white, and 1 spotted dogs. Okay, so there are 3 black, 4 brown, 2 white, and 1 spotted dogs. So what is the total number of dogs in this place? 10. There's 10 dogs over here. And so now the question says you randomly choose 1 dog to walk. So you randomly choose 1 dog to walk. And so you would return this is a choose 1 dog to walk, and then afterwards you will take another dog at random to walk with the first, what happened? The first dog. So the situation is you choose 1 dog at random, you go take a walk, you come back, you take another dog, and you take that dog with the first dog and you go for another walk. So the first dog will walk twice.
Why don't we just leave that dog? Yeah, and then use the other dog to fight that dog.
Well, this doesn't make sense because the original question was you put the dog back and then you take another one. But that would be that would be independent events now. But we want to practice on dependent events. So we're going to do some math on dependent events.
Have all the dogs taken their shot?
So, what is the probability that you take 2 brown dogs together? What is the probability that you take 2 brown dogs together? Priscilla, what's your question?
No, like, she asked me who my favorite singer is.
What's that to do with brown dogs? So this is an example of dependent events, because if you take the first dog, you have to calculate what the probability that the first dog is brown. Then when you come back, you take another dog with you. Then, there's going to be one less dog and there's going to be one less brown dog. So we have to calculate the probability of that being another brown dog. So first of all, we want to calculate the probability of brown, BR for brown dog. And so how many brown dogs are there? There are 4 brown dogs out of 10 dogs. So that is going to be 4 out of 10. And then the probability of you choosing a second brown dog, given that you have chosen a brown dog the first time, so that's going to be probability of brown given brown. Well, how many brown dogs are left? 3. How many dogs are left? 9. So that's going to be 3 out of 9, which means that the overall probability will be probability of brown times the probability of brown given brown is equal to 4 over 10 times 3 over 9. And so we can simplify this probability. So that's 2 out of 15. Now, guys, when we first looked at this example, who thought that it was going to be a high chance of taking 2 brown dogs? Because there's 4 brown is most. 4 is the most, right?
How can you take a dog at random? You know what?
Don't ask. This is math.
Blindfold and just grab one.
Yeah, but they gotta put a leash. Dogs are the best.
Okay, listen. Thank you. When we first look at the question, the number of brown dogs is actually the most. So we may have assumed that choosing a brown dog would be the highest probability. And then if you choose 2 brown dogs, in fact, once you calculate it, it's actually just 2 out of 15. So it's only 2 out of 15 chances that you would choose 2 brown dogs to go at the same time. Okay? So what time does our lesson end? Our lesson ends at 1:45. So we have a good amount of time for us to do some homework. Oh, you don't have the exercise packets with you, right? How should I do this? So your homework is exercise 13.6. Questions. And before I give you the questions, I need to check the question first. Please copy down the questions. Okay, have we copied down the question numbers?
Yeah.
Please copy down the questions first. Everyone. Janice, have you copied down the question numbers? Have we copied the question numbers? Yes?
Did you focus on power school yet?
Is this not on PowerPoint?
Printed it. Oh yes, I printed it. Yeah, I printed it. Good job, Cedric. You printed it.
It's hard. Don't know. Even I don't know. If you copy down the questions, then I have put the questions up on screen over here.
This is 13 to 6, right?
Yes.
What's the question?
I can't hear you. How about the events are independent or dependent?
You know the we have dropped it all the way to I'll try to start it and then
Okay, I'll give 5 minutes and then I'm scrolling down. So we need to finish the first few questions within the first 5 minutes. English. Wow.
so appropriate.
4, 8, 9, 10, 16, 17, 18, 19.
I can't remember myself.
Probably. I can't remember. The questions are here. 4, 8, 9, 10, 16, 17, 18, 19.
They didn't say this. That's why that's actually
Guys, can we please keep quiet? Excuse me. For 8, 9, and 10, the probability is already given to us. So probability of A happening is 0.9, and the probability of B, given that A has happened already, is 0.5. You are required to find the probability of A happening and then B happening afterwards. That's conditional problem. That's our dependent probability. Okay? So it's just probability of A times the probability of B given A. You multiply these two together, basically.
So it's 0.9 times 0.5. That's it? That's it? Can you calculate?
that's why I'm also confused.
And do you remember what it is?